Hello everyone, I'm Vidya and today I'm going to walk you through the concepts of Fermat's little theorem, which is also called as Fermat's theorem. Now, Fermat's theorem has got a number of applications. As discussed in my previous video, prime numbers are something which is very important in cryptographic application. Most of the public key encryption algorithm, may it be RSA, may it be elliptic curve cryptography, Diffie-Hellman key exchange, all these are based on prime number and they use modular exponentiation computation. So always there is a need to find whether a number is prime or not, whether two numbers A and B are relatively prime or not, and moreover we also have to do modular exponentiation operation. All these things are done very easily if you use Fermat's theorem. Okay, so Fermat's theorem allows us to know if a number is prime. Fermat's theorem allows us to know if two numbers A and B are relatively prime. The prime application of Fermat's theorem is it does modular exponentiation operation very easily. So RSA, ECC, Diffie-Hellman, all these algorithms and many more cryptographic applications are using modular exponentiation. And this operation is done very quickly in no time using Fermat's theorem. So Fermat's theorem speeds up the process of computation. That is the reason Fermat's theorem finds its place in cryptographic applications. So let us now go ahead to understanding the concept of Fermat's theorem. So what is Fermat's theorem? Fermat's theorem states that if we have a prime number denoted as P and we have any integer denoted as A, and A is not divisible by P, okay, that means the greatest common divisor of A comma P has to be 1. It means that A and P are relatively prime numbers. Now students, I have explained you what is a prime number, what are relatively prime numbers, how to test if a number is prime, how to test if two numbers are relatively prime in my previous videos. So I would request you to first brush up all those concepts so that you can solve these numericals very easily. So Fermat's theorem says that A raised to the power of P minus 1 mod P is congruent or equivalent to 1. So this theorem basically allows you to directly replace the computation of A raised to power of P minus 1 mod P by 1. Now if you see here, A raised to the power of P minus 1 can also be written as A raised to the power of P, and A raised to the power of minus 1 is now shifted on the right hand side and it becomes A. So you can also write the theorem in this format, that is A raised to the power of P mod of P. The answer of this computation turns out to be A, and when you write it in this particular format, it is known as alternate form of Fermat's theorem. So guys, this is the entire story about Fermat's theorem. So let us quickly revise what is Fermat's theorem. So if P is a prime number and we have any integer A such that A is not divisible by P, that is A and P are relatively prime. What do you mean by relatively prime number? That means GCD of A comma P is equal to 1. So if you have two such numbers, then Fermat's theorem states that A raised to the power of P minus 1 mod of P is congruent or equivalent to 1. And you can also write this theorem in an alternate fashion, and that is known as alternate Fermat's theorem. So what is the use of these theorems? Whenever you are asked to compute A raised to the power of P minus 1, you need not compute it in the traditional way. Let me say if I am asked to find 2 raised to 1000 mod 13, this is known as modular exponentiation computation. I've taught you the traditional way of doing it in my previous videos. So you can just check out the traditional way in the video which is called as modular exponentiation computation. So you can do it in traditional way and you'll understand that it is quite lengthy to do it in a traditional way. So the other way of doing it is to apply Fermat's theorem. In Fermat's theorem, you eliminate some steps of traditional method directly by replacing A raised to the power of P minus 1 mod P as 1. Since you already know that this theorem exists, you need not do the computation till you reach A raised to the power of P minus 1 mod P. You can directly replace it with 1. So this makes computation very fast, and hence this is one of the reasons why Fermat's theorem is used in cryptography. It makes the computations very fast. So guys, I hope all of you understood the concepts clearly. So with this, we come to an end of this video. Check out my next video. So thank you guys. Stay healthy, stay happy, stay blessed, and see you all in my next video.